Hey kids, welcome to another video. I think you're gonna like this one. This is the mid-module 1, and I made up my own little test prep to get the kids ready because it's such a challenging module and it's just a really challenging test. So I changed a lot of the numbers on it so that you're still getting the skill practice, but it's just kind of my own little test prep, gives the kids a chance to see what's coming, but without actually giving them the numbers, so we can all kind of learn how to do it, or at least review the skill before we jump into the test. So let's get started. In the first part of Module 1, we have comparing decimals or whole numbers, decimals, anything. You should be able to compare it. So I require my students to write each part in standard form before comparing. So you should write that down, make a new set of instructions for yourself, and then do it. Okay? Now these are in standard form, but when I compare decimals, I'm going to use the strategies that we have learned together, which is line up the decimals, okay, as your anchor. And the anchor is going to hold everything in place so that you can compare place value positions better. So this one on my test prep, and you might wonder, oh, where can I do this? I don't have a copy of this. That's okay. Just have a blank piece of paper and you can write all these down, and it will help you. It will give you this practice. So I have 4/10, 0.4, and then I have 327 thousandths, and we're going to line them up according to where the decimal is, line up the decimals, and then all the place value positions fall into place. And you can see, and this is another strategy, if you fill in the blanks with the zeros, it becomes very easy to compare 400 to 327. We're not just comparing 4 to 327. Some kids will say, this is really big, but really it's only this place value position that matters because 4 is greater than 3. So this is irrelevant now. So the 4 in the tenths place has a greater value than 327 thousandths. So that is true. Another one, 8 thousandths. Now, we were going over this in class and everybody says, what? It's like they're trying to trick you. Yeah, they are. They want you to think. So when I see this, I go, okay, I've got thousandths. I'm going to put my decimal here and put in some blank lines, and I'm going to fill in the blanks so I can hop around. So I'm going to outsmart them. 8 thousandths, that's over here. 300ths, that's here. I have nothing else, which means I can put a 0, and I have no whole number, so 0.038. Line them up and compare with 0.036. Now you can see that all that the same, lined up by the decimal, same. Here is our comparing column. 8 is bigger than 6. That means this one is bigger on the left. Okay? So follow that strategy. Let's do another one. 2 in the tens place. All right, if I've got tens and ones and a decimal, then I've got tenths, THS, I've got at least this, ooh, and thousandth, hundredths, thousandths. Now fill in your blanks. 2 tens, 3 tenths, 1 thousandth. What else goes in here? Well, you fill in with zeros. We have to fill in, if you have digits all the way away from the decimal and you've got blanks in between, you have to fill those with zeros. So I have 20 and 301 thousandths, and then I'm going to line up my 30 and 42 hundredths and put a 0 there just for fun. And you're now comparing, always starting at the left, place value positions all the way out here. This is the one that matters, and 30 is greater than 20, or 3 is greater than 2, if you want to think about it that way. Another one, put this in standard form. Watch out! Yes, it's tenths, but that means that I have what? 24 tenths. It stops here. We are not going into the hundredths place at all. A lot of students will put 24. And I'll say, nope, because it has to end in this spot right here, the tenths. So it's 2.4 compared with 3.4, and this is our comparing place in the ones. 3 is greater. Let's do another one. When they give you expanded form, please watch for the pluses, okay? Because that's going to be in between your powerful operations. Multiplication has more power than addition. So I'm going to find these multiplication signs and group or collect or join the numbers that are on both sides of the multiplication sign. So this and this have to be together inside the parentheses. The plus will be between because we're going to join unlike groups. Look, a multiplication sign. Let's grab the 4 to the left and the 100 to the right and collect those in one operation. Keep the plus outside. Put the multiplication inside. Now, this has to be solved before we can get our number in standard form and compare. So if I have 10 cubed, remember that that has a value of 1,000 because it's like 10 times 10 times 10. Okay, 100 is here, 100 times 10 is 1,000. Or count the zeros, 1, 2, 3. So then I have 2 times 1,000 for 2,000. That's something I'm going to add to my next value. 4 times 100, 400. 6 times 1/10, so the value is 1/10 of 6. So that's going to be added right here, 6/10. And I want to use decimals because we're going to be adding up all these whole numbers, okay? Now again, combine the multiplication facts. This is outside. Combine the multiplication part. This is outside. Combine the multiplication. So 2 times 1,000, which is what we just set up over here, 2,000. Plus 4 times 10 squared. Well, what's 10 squared? If that's 100, then it's going to be 400. And then if this is plus 6 times 1/10, that's a lot like this one. Exactly the same. So if you add these up, or if you at least look and see that it's 2,000 plus 400 plus 6/10, yes, these are equal. Okay? Now here's another one. Okay? Join the things that are multiplied, leave the plus out of it. Join the things that are multiplied, there's no more plus. This is already in standard form, so let's work on this one. 5 times 1/10. Well, I know that that's going to be 5/10. How about this one? 4 times 1/1000. Well, where does that go? Tenths, hundredths, thousandths. Skip that, put the 4 here, and you have to fill in with a 0. You can put this 0 here too to hold your spot. So if I have 0 and 504 thousandths compared with, and write this carefully, 0.540, then I have to compare, starting at the left, if they have the same number of place value positions, which they do. Okay, this one's not going to help me. These are the same, so that doesn't help. Ah, they're different. This one with 540 is greater. Here is the 540. It's greater. Okay, so be very careful. And remember that the symbol greater than or less than, okay, so the big number is going to go on the 2 sides, and the small number will be over here with the single dot. Sometimes people will do this, and I'll say, alligator mouth, and they want to take a big chunk of their food. Something like that, whatever helps you. Okay, now if you get to this one, you have to think about what a place value chart looks like, and you have to know the names of the positions. Now, if this is 3 and 33/100ths, let's say, then I need a place value chart with 3 positions. I need to know their names. I'm going to call this ones, put the decimal. I'm going to say tenths, and hundredths. And I'm going to model this just like that. That's really all you have to do when you model, is show that you remember the names of the place value positions. Okay, your number may be different on your test, so you have to know all the positions. But what you have to do with this is to explain, use your model with words and numbers to explain why each of the digits has a different value. Why is this 3 different from this 3? Or why is this different from this? Be sure to use these words, and this is kind of the key here to show that you understand. So what you would say is, for example, the 3 in the ones place is 10 times as large as what? Well, it's 10 times larger than the 3 in the tenths place. So 10 times as large as the 3 in the tenths place. Okay, because any number to the left has 10 times the value of the number to the right, the digit to the right. Okay, then I can say conversely, because I have to also show that I understand the flip side. I could say the 3 in the tenths place is 10 times as large as the 3 in the hundredths place. So I could continue on, but that would just show that I understand how the left is greater than the right. But I have to use this phrase too. So now I'm going to say the 3 in the hundredths place. Let's use this one and this one instead. Hundredths place is 1/10 as large as the 3 in the, just to the left, tenths place. Okay, and you could use this one. The 3 in the tenths place is 1/10 as large as the 3 in the ones place. So if you're going to the left and you're saying the one on the right is, then the one on the right is 1/10 of the one on the left. If you're starting on the left and you say this one is, then this one is 10 times greater or 10 times as large as the one on the right. Okay, so you can use different place value positions. It doesn't matter as long as you know that the one on the left is greater or 10 times as large as the one on the right. Okay, this one is 10 times as large as the one on the right. This one is 10 times as large as the one on the right. This one is 10 times as large as the one on the right, and so on. And then if you go backwards, the one on the right is 1/10 as large. Okay, another problem. So if I have 3 and 33 hundredths from part A, this is B, times 10 to the 4th power, well, what does that equal? That has 4 zeros, so it's 10,000. Explain the shift of the digits and the change in value of each digit. So if I take 3 and 33 hundredths and I multiply it by 10 to the 4th power, that's a shift of 4 place value positions, which are going to make the number 3 go 4 positions to the left. So I'm going to end up with, okay, and you can make a place value chart if you need to, whatever you need to do. It's going to go to the tens, to the hundreds, to the thousands, to the 10,000s. That's the 4 switches. 3 in the 10,000s, this one follows along. 3 in the 1,000s, this one follows along. 3 in the hundreds. Get back to the decimal, and your final answer is 33,300. Now that's for this problem, but of course these are practice problems, not like on the real test. So I have to explain the shift of the digits and the change in value. Now I want to tie into the exponent. Okay, if the exponent has 4 zeros, this one does, then shift left, shift digits, let's say. Let's shift the digits left 4 times, okay, to match the zeros. Okay, because each zero represents a shift of 1 place value position. Okay? So the change in value of each digit, well, it's going to change 4 times. It's going to be 4 place value positions greater. So each digit will have a value. There's the bell. Time to go home. That is 4 place value positions greater. And we're talking about greater because we've multiplied. Okay, if it was division, we'd be switching to the right. Look, just in time for C. Divide the product from B. Now, this is another tricky thing. The product from B is here. You have to know that product means answer to a multiplication problem. So divide the product from B, 33,300, divide it by, look, how about 10 cubed? Then we have to explain the shift of the digits and the change in value of each digit. So this one being divided by 1,000 means 3 shifts. Division means take the digits down to lower values 3 times. So this is going to go 1, 2, 3. It's going to end up in the tens place. So I end up with 33 3/10 as my final answer. And the digits, this is your explanation, will shift right, okay, to smaller place value positions 3 times because of the 3 zeros. Okay, so that's a shift of 3 place value positions lower. It shifts 3 PV positions lower or lesser. Okay, yes, lesser is a word. Okay, so let's move on. Now, here's rainfall. Rainfall collected, this one is about rounding. Rainfall collected in a rain gauge, don't get confused by the word, it's just a tool to measure rainfall. And it was found to be this amount when rounded to the nearest 10th of a centimeter, okay? Now, circle all the measurements below that could be the actual measurement of the rainfall. So what you have to do on this problem is you literally need to round to the nearest 10th, 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 and 10th, each of these. So put a box around the rounding place and the helping number, and that will easily help you round the numbers. So 19 will round to what? 20, so you'd have 4.200. 24 will round to 20, so you'd have 4.200. 26 will round to 30, so you'd have 4.300. And 16 would round to 20. So you actually end up with this one, and this one, and this one that would all round to 4 2/10. Okay? So now that I've done these, I'm going to do part B, which is also confusing because it says convert, which means change, the rounded measurement. Now kids are always going, what? Oh my gosh, and then they take all these. Nope. The rounded measurement is here, 4 2/10. That's rounded. And it's centimeters up here. So I need to change it to meters. Equals how many meters? You need to write an equation to show your work. So I'm going to take my 4 2/10, and when you convert, you have to think of 2 things. This is the activity where we did 2 things. First of all, do I multiply or divide? Because I'm changing from centimeters to meters. So since these are tiny and this is bigger, I'm going to have fewer of these. So my number needs to get smaller. The way I make my number smaller is by dividing. That's my first decision. My second decision is by how many places. And that was using your King Henry chart. So if this is centimeters, to meters, remember it's a 2-position shift. So it's going to be 10 squared. If you want to use 100, that's fine as well. So 4 2/10 has to shift 2 positions smaller, 1, 2, in order to get the correct answer in meters, and that would be your answer. Okay, and we did the equation to show our work. All right, now there's just a bit left. There's one more problem, but it has multiple parts, okay? So 4, A, B, C, D. It's all about comparing, okay, and rounding. Here again, more rainfall totals for cities in New York. So I've changed all the numbers, but not the names of the cities. Now put the rainfall measurements in order from least to greatest. First battle, you have to know what least is. That means the littlest, greatest means the biggest. Write the smallest total. This is your number 2, step 2. First put them in order. Second, write the smallest total in word form and expanded form. So you have to do 2 things. There's like 2A and 2B, okay? So first of all, let's put these in order. What I want you to do is write them like this. Just write them separately so you get to have more space. 1.6 and 1.352. Write them out up here. Once you have them written, fill in all the blanks with the zeros. Next, we have to put them in order from least to greatest. Notice that there are 2 zeros and 2 with 1s. So only compare with these 2 first. The first 2 are going to be having the zeros at the beginning, or whatever is the least. So if it's least, label it, okay? Which one's lesser? It's going to be the one with the smaller number, 0 and 214 thousandths. If you put a semicolon in between it, lets people know that now it's a break. Okay, don't use just a comma because then it might look like 214,000. The next one is this one, 0 and 470 thousandths. It's okay if you leave the 0 there because that is equivalent to 47 hundredths. It's the same value. We have 2 more. So these are done. Now I'm comparing these. They both have 1s here, so that doesn't help. This is the column where I can compare. And if I'm trying to go from smallest to bigger to bigger to biggest, then I need the one that is not the biggest, 1 and 352 thousandths. And finally, the one that is the biggest. Now, when you look at these, you're comparing 214 to 470. And really 352 to 600. So that makes sense that this is the least and this is the greatest. I'm not done yet. We have to write the smallest total in word form. So write out how you would read it properly. 214 thousandths. Now your answer or number might be different, so you'll have to write it in word form. Okay, word form, here you go. And we have to expand it. So if I have 2 times 1/10, put it in parentheses. Then remember, plus in between. 1 times 1/100th plus 4 times 1/1000th. Don't forget your parentheses to group each multiplication problem. Done with A. Now we're going to round each of the rainfall totals to the nearest tenth. Write them again. 0.47, 0.214, leave a little space, 1.6, 1.352. If you want to fill in with zeros, that can also help. We're going to round to the nearest tenth. Notice I lined them all up so I could identify rounding place and helping number all in one box. Okay, so I'm rounding to this place. So this number, 47, would round to 50, or 5/10. This number would round to 21 rounds to 20, or 200 thousandths, 2 in the tenths place. This one already has a 0, so it actually doesn't change, okay, because this is a little number. It would not change the 6. Don't go changing. And then this one is a 5 right smack in the middle, so 35 would round to 40. So these are the rounded numbers. Make sure to either put this or the name of the city to go with your rounded totals. You have to connect it to something. You can't just put a list of numbers and not connect it to the name of the city, because maybe I don't know that you're connecting this one to New York City. Okay, so give something to show that you understand that this is rounding to this. Don't just put the answer. Show the work. Show the work. Okay, imagine New York City's rainfall is the same every year, which would never happen, but that's okay. We'll just pretend. How much rain would fall in 1,000 years? Let's go back up to New York City and take the 1 and 352 thousandths. In 1 year times 1,000, how would we change this number? Pop, pop, pop. 1,352, 3 shifts. Then I don't have 1 in the ones place. I have 1 in the thousands place. Put a comma instead of a decimal. Label it. We would have meters. Make sure we label it correctly. Not inches of rainfall. It's meters of rainfall according to this. And then this is connected to this. Same question. We just have to write an equation using an exponent that would show, express, very fancy word for show, the 1,000-year total rainfall. Then we have to explain how the digits have shifted position and why. So take this same equation, sort of, but instead of using the whole number, use the exponent. So what does 1,000 look like with an exponent? 10 cubed, okay? And remember, I've changed a lot of these things, so you can't use this on your test to copy. It's not going to be the same. You have to think about the numbers on the test. So this was going to give you the same answer, but we just have to explain how the digits have shifted position and why. The digits shifted 3 positions to the left because of the, you can say 3 exponent or 3 zeros, okay, and left because we're multiplying. There you go. And so click subscribe, come back again. I'll try to help you on some more math stuff. This Eureka Math is super hard, super challenging, but I am trying to do my best to help you guys get through it successfully. So I hope this video was helpful, and we'll see you on the next one. Have a great day. Bye.